In the last class, we discussed the problems on projection of planes, where the planes are resting on HP with one of its edges. Right? We solved two, three problems, and I asked you to get one solution for a set square problem also. I hope everybody has been doing that because just practice these things is very important for you. And once the classes starts, I need to evaluate all those problems for you. Okay. Then today I will going to upload one assignment question, assignment number 1. So I mean having 4 problems. So I'm going to put it in the class Google Classroom, and please note down those assignment problems and try to solve those things, and you have to upload those. Okay. So you have to do it in a sketchbook, and you have to scan it, and you have to put it in the Google Classroom. Okay, I will go to by today evening it will be uploaded, and I will go to share the Google Classroom code also with you. Please download those assignments and please start doing it, and just submit it to me by next Tuesday. Okay, by Tuesday I want all your sketchbooks assignment should be submitted. Okay, yeah. Hope everybody is having the sketchbooks and the drawing instruments. Okay, so today we will going to start with the second type of problem, that is the planes resting on HP with one of its corners, resting on HP. So we're going to solve those problems. So please make a note of these problems in your sketchbooks. We're going to start those problems, and I'm going to do it on a whiteboard. And simultaneously, you can start doing it on your sketchbooks also. Okay, I will going to share the problem now. So please make a note of those problems and just start doing it on once I start it on the sketchbook. Okay. Yeah. Yeah. Today we will going to start with the position of projection of planes. A plane resting on one of its corners on HP. Because this is the second type of problem what we just discussed in our engineering drawing. The first was a plane resting on one of its edges on HP. So that's what we solved in the last class, last 2 classes. Now we're going to start with the planes which is resting on one of its corners on HP. So what we are shown here is the initial position of the different lamina. So when the lamina is resting or a plane is resting on one of its corners, so please remember that the corner should come to your left. So you have to rest it on the corner. Especially this happens in the case of a triangle and the pentagon. So because they have a corner and side will be the opposite when it is rested. So therefore, please look at here. This is the initial position of the different lamina, which is resting on one of its corners on HP. So when you want to start a projection of planes for any problems of this type of laminas, so this is the initial position. The first position should be like this. Look at this in triangular lamina. So what's happening? The corner is coming to your left. When the edge is resting, edge was to your left. So now, since the corner is resting, the corner should be your left. And similarly, in the case of a square, look at the square. The corner is resting. So previously we have called edge was resting. Similarly, in the pentagon, look at the pentagon. Pentagon, the corner is coming to your left. And similarly, in the case of hexagon. So this is the initial position of triangular, square, pentagon, and hexagon lamina resting on one of its corners on HP. So if you get any problem on lamina, on any of these laminas resting on corners on HP, so you have to start, or you have to initial position, you have to begin with this kind of position. Okay, I think you are following. If you have any clarification, you can talk to me at the end. Okay, so now let us start with one simple problem. I will take one problem directly. The procedure remains same, so there will be no change in the procedure. Only thing you should be very careful while you are projecting the initial position, when you are drawing the initial position. So the initial position should be like this, you're supposed to. Okay, so please take a pen and your sketchbook And please make a note of this problem number 1, which is on the triangular line. Okay, so please make a note of this problem. A triangular plane lamina, of sides 25 millimeter is resting on HP, with one of its corners touching it, such that the side opposite to the corner, on which it rests, is 15 millimeters, 15 millimeters above HP, and makes an angle of 30 degrees with VP. Draw the top and front views in this position. Draw the top and front views in this position. Also determine the inclination of the lamina to the reference plane. Yeah. So this is a problem. A triangular plane lamina of sides 25 millimeter is resting on HP with one of its corners touching it, such that the side opposite to the corner on which it rests is 15 millimeters above HP and makes an angle of 30 degrees to the V. Draw the top and front views in this position. Also determine the inclination of the lamina to the reference plane. So this is a typical examination problem for you. So I was talking in the last few classes. So you're supposed to be, when you just get a question, you have to read the question in such a way that so it should be a 5 points needs to be clear. One is the type of a lamina. So in this case, it is a triangular lamina. Second one, whether it is resting on HP or resting on VP. So in this problem, they have given it is resting on HP. And the third important thing here is whether it is resting on corner or side or edge. So it is resting on the corner. And the fourth important thing is the inclination with respect to HP. So in this case, when you look at this problem statement here, the side opposite to the corner on which it rests is 15 millimeters above HP. So this is another type of giving a data with respect to the inclination with respect to HP. See, in the previous problems, what we just observed, they used to give the angle, the inclination of the surface of the lamina with respect to HP was given in terms of an angle. But in this problem, what they have given is the edge which is opposite to the corner on which it rests, which is 15 millimeters above HP, means you have to tilt the lamina in such a way that the corner should be on HP and the side opposite to that corner should be 15 millimeters above HP. So means in order to satisfy that condition, so you have to tilt the lamina or you have to incline the lamina with respect to HP such that the corner is touching the HP and the edge opposite to that corner will be 15 millimeters above HP. So once you get this, when you satisfy this condition, then you have to find out or you have to determine what is the inclination? What is the inclination of this lamina with respect to HP? So this is the one thing. So this is the fourth point what you should be very careful. And the last point is inclination with respect to VP. So here the edge or the side which is opposite to the corner is making an angle 30 degrees to the VP. So these are the five important things you should be very careful. You should observe and you should note it down before you start getting a solution for any problems in the engineering drawing, right? So now we have to draw the top and front views on this position. Also determine, look at the last statement there. Also determine the inclination of the lamina to the reference plane. This is what is asking. Once you incline or once you tilt the lamina in such a way that it is the side opposite to the corner on which it rests is 15 millimeters above HP, then it makes an angle. It makes an angle with respect to HP, which they used to give it in the previous problems. Now we need to find out or we need to determine what is that angle of inclination with respect to HP. So this is the problem statement, very important problem. So similar type of problems will be there on pentagon and also pentagon also. You can solve those problems later. Okay. Let us start solving this problem in sketchboard now. So please try to have everybody's sketchbooks and drawing instruments. Simultaneously, you can start doing this. Okay. Yeah. So please observe this and please try to solve these problems simultaneously. I'm going to do the triangular lamina problem now. Okay. Yeah. So first we have to draw a line, XY line of XY line we need to draw. Okay. Then mark those things as X and here it as Y. Next comes VP and HP. This started doing simultaneously on your sketchbooks. Okay. So after making XY line and the VP and HP, let us start with the initial position. So the lamina is a triangular lamina. It is resting on HP, resting with one of its corners on touching it. So these are the three important conditions you should be noted down. You start the initial position. Okay. So first we will going to draw a 25 millimeter triangular lamina. It is an equilateral triangular lamina. Okay. So annotations. Let us start here with A. So simultaneously, please start doing. This is A. and this is B, and this is C. Okay, an equilateral triangular lamina of side 25 millimeter. This is a 25 millimeter resting on HP. So therefore, the true shape and the true size, you directly get it in the top view, so which you can project it on the horizontal. So 25 millimeter equilateral triangular lamina resting on HP with one of its corners touching HP. So therefore, the corner is to your left. So please construct the equilateral triangular lamina in such a way that the corner should come to your left. So this is the condition where you will go to satisfy sorry, at the end. So showing the corner is resting on HP. I will tell you, I will show that a final position how we can satisfy that condition. Okay. I hope everybody is doing. If any clarification, you can make at the end. Now, we want to get the front view of this. So for front view, so please project it. Procedure remains same. There will be no change in the procedure. Only the initial position and some data might be different. So you should be in a position to note those data and you should get the projection. Okay. So now, so as I was talking in the last class, so you are observing this triangular lamina from the front. So when you see from the front, you can see only the 2 points, the points which are nearer to the observer. Observer is here and you are observing the object, and you can see only the 2 points A and B, and the edge which connects the points A and B, it is AB, which is seen in the front view. But C, which is just behind B, and it is collinear. So therefore, C will coincide with B and it is not visible in the front view. So therefore, in the front view, you can get only a straight line with the 2 points A, B, which are visible, and C, which is behind B, not visible, coincides with B, and hence we can show it as an invisible point. So now we can draw the front view joining these 2 points, is the 2 end points. Okay, this is the front view now. Now you can mark it as this is A dash, the front view, and this point will be B dash, which is visible in the front view, and C, which is not visible in the front view. This is how we will go to draw the initial position of an equilateral triangular lamina resting on HP. So this is a very simple, I think this is one what we have been discussing in the 2 classes previously. So now, so in the previous problems what we discussed, so they used to give the lamina is inclined to HP to some angle. They used to specify the angle, and we used to incline the lamina and we used to show what is the angle of inclination with respect to HP. But in this problem, what he has given is the edge opposite to the corner on which it rests. So please observe everybody. So this is the corner. A is the corner touching HP, and the edge opposite to this corner is BC. Okay. So what he says is this BC is 15 millimeters above HP. So we have to satisfy this condition in such a way that the corner A should be touching HP, that is XY line, and the edge BC, that is B dash and C dash, should be 15 millimeters above HP. So for that, to satisfy that condition, what we're supposed to do here is, so in the second position, I'm starting with the second position now. This is the initial position. In the second position, what we do, we have to satisfy the condition that the edge which is opposite to the corner on which it rests is 15 millimeters above HP. So this condition can be satisfied by just tilting the lamina such that the corner A dash should be on the XY line, but the edge BC should be 15 millimeters above the XY line. So this satisfies the edge is above, 15 millimeters above the XY line. So for that, what we can do? So first you draw a line. So measure 15 millimeters. Please, everybody can listen over here. You can see here. Afterwards, you can draw it in your sketchbook. So this is very important. Once you understand this, rest of things are very simple over here. So please, everybody, I want everybody to have your kind attention here. Here, what happens from the XY line? Measure 15 millimeters. He is given it is 15 millimeters above XHP. So therefore, measure 15 millimeters from the XY line and draw a line, very thin line. It should be a thin line. Measure 15 millimeters above the XY line. Okay. So this distance is 15 for you. 15 millimeters above the XY line. So now on this XY line, mark the point A dash. Anywhere. Anywhere you mark the point A dash. I will just mark it as A dash over here. Point A dash. Okay. Any point you can mark on this point here. I will just point out this. Okay, no problem. So mark one point, that is A dash on the XY line. Okay. Take a compass. Set the radius equal to A dash and B dash from the front view. Take a compass. Set the radius equal to A dash and B dash. Okay. Now, with A as a center, and the radius equal to A dash and B dash, you draw an arc. Cut the arc. So I will repeat once again. So in the second position, measure 15 millimeters above the XY line, draw a line, a locus line. Okay. Mark a point on the XY line, which will be denoted as an A dash because you are tilting the lamina on the corner, that is A dash should be on the XHP. So therefore, mark the point A dash on the XY line. Now come back to the front view of the first position, initial position. Take a compass, set the radius equal to A dash and B dash. Okay. Then with this point what you mark A dash. Okay. Then with that radius, what is you have set it for A dash and B dash, cut this locus line which you have drawn for 15 millimeters. Now you join the points A dash and the arc what you have drawn over there, you join it. Okay, so this point will be for you B dash. So now you can measure this angle with respect to the XY line. Now you measure this angle. What is this angle? You measure and get me the value. You have to measure this angle. Then let us proceed for the next step here. Upwards you can measure it. I will just complete this and upwards I will proceed. Now, this once you get this front view, you are showing the lamina is such that it is inclined such that the edge opposite to the corner is 15 millimeters above HP. See, this is B dash and C dash is 15 millimeters above HP. Now you have to get the top view for the second position. Draw the projector lines. So please look at the projector lines, and the thick and thin lines is very important over here. Okay. Similarly, horizontal projectors. Now, first you mark the points over there. So where the horizontal projector meets the vertical projectors. So that's what I was talking. Intersection point will be marked first. So this point will be A for us. And this is B. Intersection points. Please make a note of that. And this will be C. Now you can join all these points with a thick line. This is the second position, so where we are satisfying the condition that the lamina is inclined in such a way that there is the side opposite to the corner on which it rests is inclined to HP, or it is at a distance 15 millimeters above HP. So this is the second position we are satisfying. So one thing you have to measure is you have to measure this angle. So this angle you need to measure with respect to HP. So this is what the last statement what they say. So determine the inclination of the lamina with respect to the reference plane. Now the third position, the last position, the final position here is the edge which is opposite to the corner. Again, the BC. BC is inclined to VP at 30 degrees. So now we have to tilt this, the second position top view triangle. So this is the diminished size or diminished triangle. So this needs to be inclined to VP such that the edge BC makes an angle 30 degrees with respect to VP. So this is the one what we are going to do. So for that, so same procedure what we were doing. So draw a line for 30 degrees. Okay. So on this 30-degree line, this is 30. Okay, on this 30-degree line, you have to draw BC. So mark a point C on that. So anywhere you mark C and then draw this line BC is equal to 25 millimeters only for you also. So mark it and draw. So this is point C for you. Yeah. This is point C and this is point B. Okay. So now once you get BC, measure AC and BAB and with the compass, and you can construct the triangle over here. Okay. So construction of a triangle. So with the compass only you have to do. Yeah. So this is point A for. So you are transferring entirely the top view over like a third position such that BC, the edge BC should be inclined to VP at 30 degrees. So now you can start projecting it, draw the vertical projectors. And similarly, the horizontal projectors. Okay. Afterwards, so mark the points. First, you have to mark the points. Then you can start. So intersection here, it will be A dash. The intersection here is B dash and C. C intersection is here. This is B dash. So intersection points you just look at it, and later part, so you can join all those points to get the final position.
Sir,
Just a minute, I will complete it. I will complete out after I will ask for you to give a clarification.
yes.
Yeah. So this is the final position. Okay. So in the final position, you can show that the corner, see, the corner A dash is on the XY line. It is representing, it is showing, it is resting on HP. This is the condition what is supposed to show. Okay. So please complete this. Yeah. So if you have any clarification, you can, students, anybody, if you have any clarification, you can do one by one. Yeah.
So for the last third triangle which you drew on the 30-degree line,
yeah,
is it an equilateral triangle?
No, not equilateral triangle. It is the top view of the second position. This one. Top view is there. No, second position, top view will get it. No, the triangle. That you have to transfer it over.
The angles of all the three sides of the third in second position and draw it here.
Sorry?
We should measure the same, we should draw the same triangle of the second position over here.
Yeah. So first what you have to do is, first you draw the 30-degree line with respect to VP. Okay. Then you first you draw the edge BC.
Yeah.
is there, no? The BC will be equal to 25 millimeter only, it won't change. But only the edge AC and AB will going to be diminished because it has been inclined with respect to HP, right? And as you see from the top view, so this edge length will be diminished. So therefore, so first you mark BC on XY line. Anywhere you can draw the 30-degree line, and on 30-degree line you can mark BC, and then you can take a compass, measure AC with AC as a center, draw an arc, and measure AB with a AB as a center, you draw an arc. So you will go to get a triangle.
Yes, sir.
Got it? Yeah. Yeah. Anybody, any clarification, please? Anybody is having any clarification? Divyashree, are you following? If you have any clarifications, you can make, students. These things will not be taught once again. Anybody having any clarification? So please start doing it on your sketchbooks or a sheet of paper, whatever it might be. Okay. You can unmute yourself here and you can speak to me if you have any clarification. The last 2 minutes left out for me. Please practicing it.
Sir, what should be the angle measurement in the second position?
How much you got?
Sir, I think approx it is
The 46 something I got.
46, sir.
I got 40 degrees.
Okay,
Sir, I got
just
40 degrees, sir.
40 degrees. Yeah, okay,
I got
okay.
40 degrees.
Yeah. 40, 39 to 40. Okay, no problem. Not an issue. You can get it 40 degrees. 46, just check it out, yeah. Students, are you following? Are you comfortable with this?
Yes, sir.
yes, sir.
Okay, so please practice these things because we are inevitable. We have to complete this syllabus because already we are losing so many classes. So once the class starts, we cannot make you to just tighten the schedule. So therefore, once we are free, we can start doing all these things. So please start practicing these things. So because I'm doing it at triangular lamina, you should go for a square lamina or pentagonal lamina. So like that, you can start doing if you have a solution manuals with you. Okay. So please complete this, and I will back to meet you at 9:30. So we will join at 9:30. We will solve another one problem. So by the time, please, if you have still any doubts and any clarification, you can make it with me. Okay. So please get ready with 9:30. 9:30, I will join once again.